Hello everyone, welcome to my YouTube channel. Today we are going to discuss positive real function. It is the follow-up of Hurwitz's polynomial that we have studied earlier. So let us study what is a positive real function. First of all, let us consider f of s, a function that is a fraction of a polynomial a of s and polynomial b of s. Okay, so this function f of x is said to be positive real function only if it satisfies the following four conditions. Okay. The first condition is that the numerator and the denominator of that function a of s and b of s should be Hurwitz's polynomial. This is why we studied Hurwitz in the beginning. Okay, so a of s and b of s should be Hurwitz. So how can we, what is the major property of Hurwitz's polynomial? It is basically all the poles or all the roots of a Hurwitz polynomial lies on the left half of S-plane. So that's exactly what is written here. That is poles and zeros on the left half of the S-plane. Here you know what is pole and zero, right? Poles means root of denominator gives poles and roots of numerator gives zeros. Okay, so the poles and zeros should be on the left half of the S-plane. That's our first condition. That is, the numerator and the denominator must be a Hurwitz polynomial. Then we'll move on to our second condition, that is, the degree of the numerator, that is the highest term, and the lowest term should at least differ by 1 degree, 1 power, that's it. So that's our second condition. Then we'll move on to our third condition, which is if a function f of s is equal to a of s by b of s is a positive real function, then its reciprocal is also a positive real function. And the third one is also similar, fourth one is also similar to the third one, which is sum of two positive real functions is positive real. But difference need not to be positive real. Like if I say if x is a function and y is a these two are x and y are positive real function, their sum will always be a positive real, but their difference may or may not be positive real function. Now we have first of all we have discussed the four conditions for a function to become positive real function. Now we'll move on to how to find a function whether it's positive or positive real or not. So for that we have to consider four things. First of all, as we said earlier, it should be a Hurwitz polynomial. So one of the key factor is that all the coefficient of the polynomials should be positive. That is, all coefficients, the numerator, all the coefficient of the numerator and denominator must be positive. Then only we could say it is Hurwitz. The first condition for a polynomial to be Hurwitz polynomial is all the coefficients must be positive. So here also all the coefficients must be positive, all the coefficients of numerator as well as denominator. The second point will say that all the poles and zeros should be on the left half of the S-plane. That's also a condition for Hurwitz polynomial. So all poles and zeros should be on left half of S-plane. And if any of the poles or zeros exist, if any poles exist in the j omega axis, or we call it as imaginary axis. It means in a S-plane there is s axis and j omega axis. If any pole exists in the j omega axis, they should be symbol poles. That is, there should be only one pole in the j omega axis. So they should be symbol poles with with positive residues. Next thing is the third step that we have to do in order to find whether a polynomial is given function is positive real or not. The third step will be we'll put s equal to, if a function, for example I will say if function is s plus 2 by s plus 1, then I'll put s equal to j omega. That way it will be j omega plus 2 by j omega plus 1. So that is what we mean by the third condition, that we will put s equal to j omega in the given function. Then our fourth condition, that is we'll find the real part of f of j omega. We have already put s equal to j omega, and we'll consider the real part of the answer and check whether it's greater than or equal to 0. If it is greater than or equal to 0, we could say that all the above four conditions are met. Hence, it is a positive real function. So this is how you find out whether a given function f of s, which is equal to a of s by b of s, is a positive real function. That is, we check all the coefficients whether they are positive or not. If they are positive, our first condition is satisfied. Then the second thing, if all the zeros and poles lies on the left half of the S-plane, if it is satisfied, then we'll move on to the third criteria, that is we will put s equal to j omega, and we will take the real part of that function and check whether it's greater than or equal to 0. If all these four things we have done and all of them came out to be true, then we could say that the function is positive real. If any of this condition is not satisfied, any one of these is not satisfied, we could say it is not a positive real function. So next I'll move on to an example. I'll solve an example for you. So I'm taking f of s equal to s plus 3 by s plus 2. Okay. So my first step is to check all coefficients are positive. Check whether all coefficients are positive. So in the numerator it is s plus 3, that is 1 and 3, and in the denominator it is s plus 2, so that is 1 and 2. Both the coefficients are, all the coefficients are positive. Hence our first condition is satisfied. Then we'll move on to the second condition, that is poles and zeros. How will we find the poles and zeros? That is, first in order to find pole, we will equate the denominator with to 0. So I'll get s plus 2 is equal to 0, that is s equal to minus 2. And to find out 0, what we'll do is we will equate the numerator to 0. So s plus 3 is equal to 0, thereby we'll get s equal to minus 3. On plotting this is on the s plane, we could say that is s equal to minus 2 and s equal to minus 3. S equal to minus 2 and s equal to minus 3. Here pole is represented by a cross symbol and 0 is represented by a circle. So we have plotted the pole and 0 in the S plane, and we have found that pole and 0 lies on the left half of the S plane. So that condition is also satisfied. Next, we'll move on to our third condition, that is we'll put s equal to j omega in f of s. So what I'm going to do is, our f of s is s plus 3 by s plus 2. And I am doing f of j omega, that is s equal to j omega. So it will be j omega plus 3 by j omega plus 2. So I'm taking the complex conjugate of j omega plus 2 and multiplying it with this term. I'll get minus omega square plus 3j omega minus 2j omega minus 6 divided by minus omega square minus 4. On further solving this, I will get, I'm taking minus from the denominator as common and I'm giving it to the numerator. So 4 is omega square plus 4. I am multiplying with the numerator, so I will get omega square minus j omega plus 6. Okay, so this is what I got as f of j omega. Now I'm gonna find the real part of f of j omega. Real part of f of j omega, I could just split the f of j omega like this. That is, imaginary part is the part having the j term. So I'll separate that from the existing equation. So that will be omega square plus 6 by omega square plus 4 plus, sorry, it's minus j omega by omega square plus 4. So this is our f of j omega, and I'm taking the real part. The real part is the term without the j. So that is omega square plus 6 by omega square plus 4. Okay, now assume giving a positive value to omega. If I give 1 to omega, omega will be 1, omega square will be 1. So it will be 7 by 5. Okay, and imagine giving a negative number to the omega, like minus 2 or minus 3 something, or minus 1. Then the answer will also be positive. So whichever value we give to omega, the answer will always be positive. That is greater than or equal to 0. So we have checked all 4 conditions. That is, we have checked whether all coefficients are positive, and we have checked the zeros and poles position, and then we gave s equal to j omega. Then we found the real part of f of s, real part of f of s, f of j omega. Okay, f of j omega, and with that is the real part of f of j omega is greater than or equal to 0. Now that all the 4 conditions are satisfied, so we can say that the given function f of x is positive real. That's all for today. Thank you for watching. Please do like and subscribe to my channel. Thank you. Have a nice day.